Hey guys, welcome back. So in this video, we're gonna see about the memory management of Java. So in our previous video, we discussed how the memory of Java is managed, and how a program called as GAVM is responsible for managing the memory and the processor. So let's see how the memory is internally managed by this JVM. So we have seen the internals of this JVM, how and what each part of this works. So how the class loader works and all these things. But the main part that we need to understand is the memory. So if we were to cut off all the native method stacks and pieces, so the memory can be divided into two main portions, which is the heap and the stack. So let's see what this heap and stack does to us. So for any process which is in the memory, so any process will have four sections. So it will have all the code or the text which is associated with the file or the program, and then it will have the data or the variables, the global data, everything, and it will have two set of memories, a stack and a heap. Stack as defined in the data structures, so it follows the last and first out principle, and it keeps on expanding as and when so there are more function calls on it. So eventually, when a more number of function calls are done, so we eventually uh, get into something called as a stack overflow. uh, the heap on the other side, so it is not a linear one. So it is a sort of a heap, so we can create objects wherever we want. We will just get the reference of it, and using the reference we're going to act on the object, right? Let's see how we can use them in programs, and how Java treats objects. So usually any object, so in this code we can see that so there is an int variable, so there is some student, and so there is something called as a double. So these are the variables. All these variables will reside in the stack. If this variable is a primitive one, if it is primitive, it is going to be stored in the stack itself. But see here, the string, it is not a primitive, it is an object. So since it is an object, the student will be created in the heap, and the reference will be maintained in the stack. So this is how variables are managed in Java. And and a special case for string is that a special case for string is that so the way okay, so we will have a unique area called as the a string pool. So this a string pool is actually part of the heap as well, but it is a special area which is used to manage strings only. So it will have all the predefined strings, so that if any reference of the same string object is to be uh, given to another variable, then it is going to search in this string pool, and it is going to assign it. And then we'll see, yeah, so this is okay. So we have a string, so okay, we have a stack, and there are multiple functions. So these are the call stacks of those functions. And if we are creating any object, an object is going to be stored in the heap as an object, but a string will so a string so if we are creating the same string in multiple functions, and so it is going to check in this string pool. If it already exists, it is not going to create a new instance. It is only going to return the same reference, so that every a string object which is referencing the same set of characters will be pointing to the same string object in the string pool, right? uh, Now let's look at how the objects work. So okay, so we have an object here. So we said demo obj, and obj equals to new demo. So now an object will be created in the heap, and its reference will be stored here. And what am I doing? So here I'm trying to set it to null. So if I'm setting it to null, then I'm going to lose all this connection. So it is so this object is no longer accessible to the obj. So it will be given to the garbage collector, so it will be removed from the memory later. Okay, let's see. Okay, so we have an object of boy. So initially it is referencing to the null, so since we haven't assigned anything, and then we say obj equals to new boy, so then an object will be created, so the object reference will be there in the object in the stack memory. So this is kind of the same that we discussed. So these are different ways. So okay, so in this example, let's see. So this is a class demo. So for class demo, we are creating a new object called obj. So now obj will be pointing to this one. And now, so what am I doing? I'm actually creating another reference called obj1, and I'm assigning the value obj1. Okay, yeah, and I'm assigning the a value of obj to obj1. So that, so what do you think should happen? So since the obj is only storing a reference value, the same reference value, so the same address is going to be copied into the obj1. So now obj and obj1 are now actually pointing to the same object in the memory. So if either of obj1 or obj2 were to made any were to make any changes, it is going to be visible, since they both are actually pointing to the same object. And let's see how the local variables and the objects differ. So the local variables are actually stored in the stack, and once this a frame is deallocated, then all the data might be lost. But it's not the same with an object. So since an object resides in the heap, it can be accessed if the reference is preserved with the preserved within the program. Yeah, that's fine. And actually, so the value might be same, but the way we operate in the program might make that a value to be created in the stack or in the heap. So if we were to create an so if you're declaring an int a, so it is going to stay in the stack. But if you're defining an integer wrapper class a, so it is going to stay in the heap. But still so the value is going to be same. So it is only in the case of strings that so the value will be checked if it is already present in its own a memory pool or not. And so we have discussed about this, right? So if we have two references which are assigned the a same object reference, then they are going to point to the same object. And the string buffer pool. So yeah, so let us say two strings. So two strings are pointing to a single object in this case, but in this case they are actually pointing to a different object, even though they have the same character. So why we have such difference of a behavior? It depends on the way we have created the string. So if we are trying to create the string using the string literal, so if you're saying str equals to some string in this double quotes, it is actually considered as a string literal. A string literal will be checked in the a string buffer pool, and if any other a string of the same way is found, then both of the string A and string B are going to point to the same one. But if you're creating it in a different way, like, so let's say you're saying s equals to new string. So if you are calling the construct of the string class, and you're passing the same argument, it will not check for the equality of those values. Since we have used the new operator, it is going to allocate a memory for it, and even though they have the same characters, so it will have different instances in the memory. And yeah, so if we were to set the string to a new value in the buffer pool, it is going to, so a new string will be created. So if it is not present, a new string will be created, and it will be pointing to the new string. So the old string will be garbage collected later. So this is the same thing that we discussed. Uh, okay, now let's get into something new. So here we can see something called as a string buffer. A string buffer is nothing but a mutable sequence of characters. So in string, if you were to create so if you were to append a few characters, so if you were to do some sort of manipulation on the string, it is going to create an entirely new object in the string pool. And so it is not a great way to handle strings if you were to modify them on a frequent basis. So if the modifications are more, then you might, so it is suggested to use something called as a string buffer. A string buffer will have some methods like append and sort and reverse. So using those methods, you can modify the string in place in the memory. So a new memory will not be created. So whatever the memory which was assigned earlier will be used for all the manipulation. And if any a new memory is needed, then it will be internally handled by the class. And yeah, so string buffer is actually synchronous. So we actually so Java provides us with two classes which are immutable. So one is the a string buffer and the other is a string builder. A string buffer is synchronized. So by saying synchronized, we mean that even if multiple threads are trying to access this a string buffer object, so only one thread will be able to access it at a time. But when it comes to the a string builder, it offers the same functionality, but it is not synchronized. So since it is not synchronized, when it is placed in a multi-threaded environment, so the operations might not result in a consistent value. So it might be an issue, but any which way, since it is not asynchronous, it is going to work faster than the string buffer. So it depends on the use case. So you have to choose which one on your use case. And the garbage collection. So since we had discussed that, so if you're not referencing an object which is present in the memory, so since that instance in the memory is not referenced by anyone, so it cannot be accessed anywhere after the okay after uh, after that statement in the program. So we were to remove it from the program. So another internal program which is used to remove all those unused memories is the garbage collection. So it works in two ways. So there is something called as a minor GC and a major GC. So the garbage collectors, so it is going to, so it is actually an internal process of the JVM. It is going to execute on a, so it will be internally managed by the JVM. So whenever the memory is filled, so it is going to automatically run this software and let every unreferenced object be out of the memory. So let's see the native. So this is the JVM's native memory. So in this memory, so all of the objects which are created very recently, so they are called as the young generation, and the objects which are present even from, okay, so when this works, so when the garbage collector routine works, so it will check that if this object was already, so if it is in use, so it is going to ignore that. But again when the garbage collector is called upon the system, so if it can find that the same object which was in use before is now is is also being used now, so it means that it is of an older generation. And for the next iterations, it was supposed to be collected because since it was present in the memory from a long time. So it is how it is going to segregate all those objects. And Yeah, so the garbage collection execution flow. So this is the start. An object will be created, and the reference tracking will be done. So it will check if the object is having any references are working on it right now. So if there are no references, it is going to mark it, and it is going to sweep. So this algorithm is called as the mark and sweep algorithm. It is going to mark all the objects which are having zero references, and then since it is going to sweep the memory, so the memory so usually the memory so the memory is created in some sort of a random location. So if the memory is available now, so we have to make sure that so it will be added to some other place. So it is called as compaction. So we make sure that at this unused memory will be transported to a place where it can be used, and then we will dispose the memory, and it will end the routine of the garbage collector. Right. So I think that's all about the memory management in Java.